Hey everyone, welcome back to the shop. Today we have a machining project that we're going to be performing over on the TRM 3016, and it is a subplate for the fourth axis for our new VM 3018. So the fourth axis that came with the mill right here, the way that it's designed from the factory is that it's got the keys in it and it's designed to be bolted down directly to the T-slot table there. But because we have a Saunders fixture plate in here, we can't utilize the keys on the bottom of the fourth axis there. And what I believe is a very common fix to fourth axis for vices, all kind of work holding, is people machine what they call subplates that get bolted down to the table, and then you set your workpiece down on top of that, or your work holding device. Or in many cases, and like what we're going to be doing, we're going to be machining a subplate that is bolted to the bottom of the fourth axis there that will just stay on it all the time. So whenever we want to use this, if it's not already on the machine and we're going to go and bring it over here and set it on there, it's going to drop right down onto this fixture plate. It's going to have dowel pins that set into two of these holes right here, and then it's going to have 4 mounting holes. We have just enough room where we can put a bolt here, we can put a bolt there, and then same on the other side. We have this one row available over here for mounting. You can see like right there, but I believe it's going to be in one, just like that. So 2 bolts on that end, 2 bolts on that end. That's going to hold it down, and it'll be dowel pinned to 2 of the holes there as well. All right, so that is the project, and I'm trying to get this guy done because Steve, my helpful trainer at Milltronics, he is going to be coming in next week, next Monday and Tuesday, and spending a couple days with me. We're going to be going over the 3018 here and also the new slant bed lathe as well. So I wanted to go ahead and have the fourth axis ready to go, so whenever Steve gets here, we don't have to fuss around with that. Hopefully it's going to be bolted on here and it's going to be ready to operate. I still have to attach the cables, which is not a big deal. They clamp in right here, they attach here, and they get fed through. There's a plate on the top that you have to take off. It's like a split plate that the cables come up and through, and then it attaches to those guys right there. All right, so there's a plate right up there. You might be able to see it. You just unbolt that and run the cables through there. And I believe there's one hanger that you have to drill through here to hang the cables up out of the way. So we'll work on that later. But the focus of this video project is machining the subplate for the fourth axis. All right, so I'll show you where we are on the TRM and the setup. We're going to be using the ECB 120 magnetic chucks here. I've already got these guys clamped down, trammed in a line. First thing I'm going to do is run the face mill across there. We have about 2 thousandths out of flatness there. So I want to go ahead and we'll just run down and skim those off, make sure they're nice and flat. And then this is the plate that I had the welding shop cut out for me. It's 1 inch thick, A36 plate. It'll be fully machined top and bottom. I have just enough where we can clean up the outside of it as well. So we have just enough room with our magnets. Once I stick it on here and get it centered really well, we can do all the milling, facing on the top, put our holes in there for op 1, and then we'll have a hole in the center of it, so when we flip it over onto the magnets, I'll have to indicate it, get it straight, indicate the center of the hole for the center of the workpiece, and then we'll face the bottom off, do the chamfer the outside edge, and then that'll be it. These are all the tools that we're going to be using for this job right here. Took time and got all these guys set up. We have 3 of our Technics heat shrink tools, and we did those earlier. Hopefully you guys have seen a video on this now. We have our new Technics shrink station and the Vortex cooler that we'll be using for our heat shrinking needs here in the shop. All right, so I'm ready to do some facing. I think before we get started on that, you guys might like to see the program. I had Kevin over at Mechanical Advantage help me with this program again. And we had a little bit of fun this time. He was showing me how you can use solid models in Fusion, which is very helpful whenever you're designing parts. So we were able to get the solid model of the 4th axis from Milltronics to use. We also have a solid model of the Saunders fixture plate that we were able to use on that. And we even have solid models of the earth chain magnets as well. So that was pretty cool, getting the solid models for Fusion and then being able to use those to more easily design the fixture, the subplate around that, and seeing how all the pieces are gonna align together on the fixture. That was really, really helpful, seeing the hole patterns for the fixture plate, the hole patterns for the 4th axis, and the hole patterns in the subplate that we designed all line up together. You can just see right there on the computer that they're all gonna fit, they're all gonna go together. So we'll go in there to the computer, I'll give you a rundown of the program, and then we'll get out here and we'll start making some chips. By the way, before we go in there, I was gonna show you this too. This is the new Inspire controller for the new Milltronics. We'll get more into this later, but the graphics on this has been updated and it's a lot sharper, a lot smoother looking image. I can't wait to see some of the graphics on here once we get to machining. But we're gonna go into more detail of the machine as we move forward with this and we start learning more about the VM3018. All right, guys, we got you at the computer here. So here's a look at our subplate that we designed. And what you're looking at here, this is going to be the top side, or this is the side that the 4th axis is mounted to. So you can see that we have a couple of keys designed in here. That's to align with the keys on the bottom of the 4th axis. These 2 holes here are mounting holes, and these 4 holes, so you have these 2 holes here are drilled 10.5 millimeter. It actually, on this side of the 4th axis, is drilled and tapped from the factory. So you have 2 bolts that are gonna come in from the bottom of this fixture plate. I don't know if we can flip that over and you can see. We actually have a couple of counterbore holes, so the socket head bolts will come in from the bottom, 14 millimeter. See if we can get oriented again right here. All right, and then you have another couple of holes right here. These are tapped M10 by 1.5, and so you have a couple of through holes on the 4th axis that will, these will get bolted down to right there. All right, let me see if I can, yeah, there we go. So we had it hidden, but there's your 4th axis right there. And you can see what I'm talking about. There's your 2 through holes. And if we come around here to this side, you can see on the back of the 4th axis, you have, these are tapped holes that come in from the bottom of the fixture. And you can see, this is the cool thing about the models, is that you can actually see everything align perfectly. So that's pretty cool right there. This is some new stuff that I've been learning that Kevin has been showing me on this particular project. All right. So there's that guy right there. We'll go ahead and we'll hide that one again. Okay, so if we flip this over, let's see if we can flip this over. I'm still trying to learn how to really navigate this thing better. Oh, no, this is not what we want. Here we go, wasting time again. There we go, that's the one that I want. So on the back side, that's gonna be mounted to the fixture plate. All these holes will be done, finished. All we have to do really is face the bottom side off, and then we're gonna chamfer all of those holes and then chamfer the outside edge. By the way, the 3 holes that I forgot to mention just a minute ago, these 3 holes in the center, these are all drilled and reamed 1/2 inch. The 2 outer holes are gonna be for our dowel pins to press into. The center hole is only for me to locate on. That locates the very center of the workpiece. So that's just there to aid in setting the part up. So we'll flip this back over to this side right here. And I was gonna show you as well, over here on this toolbar, we have our ECB 120. All right, here are the 2 magnets. And I like looking at it from this way right here. That's kind of the position like this is gonna be setting into the TRM mill, like so. but that's pretty cool. So we were able to actually put our magnets on here and make sure that we have our clearance right. So if we rotate up like that, you can see these holes are clearing. You can see over here, let's see if we can move this around a little bit more. I told you I'm really bad about rotating this stuff around, but you can see our holes are clearing here. And then let me go back and show you one more. We go to the front and rotate it up. This gap in the vices right here, our drill and ream, which would be coming through right here, are going to clear. So it will not hit the magnetic vices right there, okay? So that's another cool feature of having these solid models in here so that we can actually see where everything is. And by the way, the reason why it doesn't look like it's touching it right there is because it's missing the stock that is going to be machined off of the plate right there, okay? All right, so I think that's it right there. I had one more thing that I wanted to show you that was pretty cool. It's the first time doing this in Fusion with Kevin. So up here, if we go to animation, this is pretty cool. So it's showing our Saunders fixture plate that's mounted on the machine. Here's our subplate that we designed right there. And of course, there's our 4th axis. And this allows you to play it, and it shows them all coming apart. How cool is that? So it shows all 3 of them just kind of separating. And we were going to come in here and add all the bolts to this, but we were just kind of running out of time. He was telling me how cool it is. You can pull up the McMaster car files on Fusion, pick whatever bolts hardware you want, and actually import them in here as well. So when you do this animated view like this, it'll show the bolts coming out of there also. So that's just really cool. I wanted to share my excitement of some new stuff that I'm learning over here on Fusion. So Kevin is very helpful with Fusion. If you guys are needing any help with your training and understanding of how Fusion works, or even maybe you need some help with one of your designs, maybe something's giving you a problem, definitely give him a shout and book some time with him, because I know that he can help you out, okay? So thank you, Kevin, for helping me with this project. Let's go out to the mill and make some chips now. I realized that I was going to run through the animation, and I totally forgot about that. So let's go ahead and handle that real quick. We got it on. This is going to be setup 1, which is op 1, and we'll go ahead and simulate it and run through all of the processes that we're going to be doing, okay? Get this where you can see it a little bit better. So very first one, we'll go ahead and play it. We're going to be facing the top of it off just 10 thousandths and hoping that's going to clean that up. And then once we clean the top of it up with our 3-inch face mill, we're going to use a 3/4 inch end mill and mill the outside. That is a plasma cut edge on there. I decided to go ahead and make that in 2 passes. We're not in no big hurry. We're just making one part here. And that end mill will clean up all 4 sides of it. And then we'll get to our hole making. That's a spot drill. That's a 1/2-inch spot drill. We'll spot all of the holes right there. This is going to be our 33/64 drill for a 1/2 inch. These are our metric drills for our metric bolts. 1/2 inch, I'm sorry, let me just stop this right there. It's running through there fast. We're going to be drilling these center holes 31/64, and I believe I missed it. It showed the reamer in there, 1/2 inch reamer. And now we're on our tap, our M10 by 1.5 tap, tapping those 2 holes. And then now we're on our 1/2 inch end mill that's going to be pocketing out the 2 keyways, and come in with a contour, clean up the sides. And then we're going to use that same end mill to do the counter bores for the socket head bolts, which are 1/2 inch, 1/2-13. Come down here to this side and counter bore those out there as well. And then next up, we've got our chamfering tool, chamfer the entire outside of the plate, and then it's going to chamfer all the holes. And then one last feature it'll do is we're going to come in here and chamfer these little edges right there too. How cool is that? All right, we'll exit that simulation and we'll go ahead and activate setup 2. We'll flip it over. We'll hit simulate. This one's going to be pretty simple. So basically what we're doing is we're taking it down to about 7/8 thickness there. So we're taking an 1/8 inch off the bottom of it. So we'll go ahead and play that. I've got this set into 3 passes on here. It'll face the bottom of it off. Let's go ahead and get to the next. There we go. So after it faces it, we're going to counterbore the 2 holes for the 14 millimeter. And then the last phase is just chamfering that outside and all the holes. So I will have to make sure that it's trammed in well, aligned, and then line up on the center hole right there, and everything should line up good. All right, so now we should be finished here, and we'll go out to the machine and start making some chips. All right, I still got to probe these things in to find the center. We're just going to find the XY center of the entire envelope of our 2 magnets right there. We'll start with the Y-axis. I'm going to use the web on this. All right, now reset for X. Perfect. All right, we got our XY0. Now we'll just single surface off the top for our Z0. All right, that's done. I'm gonna gently make sure you go in the right direction. Bring it up nice and slow. And then take this guy out of here. I don't think I mentioned this earlier. So this is all the tools that we're using for this program. And I decided I've still got a lot of tools set up in here for our drill index production. I don't want to take those out and get things mixed up. Since we're only making 1 fixture plate, I'm just going to hand load every tool. So you can see we got them numbered, starting with our very first tool that we use, which is our face mill with 30. So we're going to be going from number 30 all the way up to a number 40. And I don't know if other people like labeling their tools like this, but this is very helpful for me. I've got a label maker that I bought, and I got this really nice label, and it puts out a nice bright bold letter there that I can see. And I think the quality of this label is really good too. I haven't had any of these things fling off or fail. They stay stuck on there, so it does a really good job. So just wanted to point that out, but we'll start with this. So this is the face mill that we'll use as a 3-inch diameter Tungaloy. I believe this one was called the Do Quad. It takes these square inserts. I believe it's an SNMU. So it has 8 corners on there. And we'll use this to face off our magnets as well. So we'll get this loaded up and get those guys faced. Okay, we're ready for our program. I'm gonna bring it down kind of nice and gentle, make sure everything is good before I bring it back up to 100% rapid. Watching the distance on my controller. And we should be going down to a -10. Zero, I mean. We're taking -10, so I think that's good. There we go. All right, I think that went well. Again, we took 10 thousandths off of that. Feels pretty good. We'll just have to blow it off. And by the way, these plates that we're milling, these are meant to be decked off on your machine when you mount it down, and they're replaceable. You can buy these from Technics to replace them, or you can make your own if you want to. But I think it did a good job there. It's got a good, nice, smooth feel to it, and we know that they're nice and flat now. So now we'll go ahead and get our steel plate and set it on here. We got to get it nice and centered up on the magnets. Make sure it's trammed in nice and straight and everything as well. So I'm going to use the old school machinist trick and just rough it in with a rule here. And we'll just split it on both ends. About 2 1/16. This one's just shy of that. And it's looking pretty good there. Now I'll just go side to side and see what we got. 2 1/16. Yeah, let me find me a little hammer to bump with. All right, that's looking really nice right there. But what I do want to do as well is I want to go ahead and make sure that the one edge of this is indicated nice and straight. We should have enough material to clean it all up as long as we're within that 1/16 of being offset, you know, on our plate there. So we'll go ahead and get this indicated next. Okay, we're going to use another old school machinist technique to indicate this. We're going to use our surface gauge. We got our Starrett number 257 surface gauge with the 196 back plunge indicator, and that is the number 57S snug that I'm using on there. So on your surface gauges, you have these pins that you can push down, and you can use these on straight edges. So our fixture plate is machined nice and straight, so we're going to use this like a fence. So we push our pins down. And I already got all this aligned just to save on video time there. Just get it really close, and now we have a fine adjust on the base here. We can go ahead and walk the indicator in. We'll bring it to our 0. All right, and now instead of having to run the machine back and forth and set a dial indicator in the spindle, we just simply slide it. All right, I know we started in the center, so if we just kind of find a spot right there, maybe you guys, I'll get you in closer so you can see this before we finish it. I'm going to dial that into 0 there. I'm just going to go ahead and do a sweep all the way down to this end and see how close I was just eyeballing it with a scale. So if I stop there, it's on 9 thousandths. So I'm within 10 thousandths, and this is on the positive side, so we need to bump this corner here back slightly. I'm going to be very gentle because it's not being held other than just gravity sitting it on there. We're just going to slide this back down here, and let me find my soft blow. I'm just going to be very gentle. I'm going to start with half of that, so that's about 4 or 5 thousandths. Remember, this is a flame cut edge or plasma cut. It's on about 1 to 2 right there. 3 to 4 right there, so really, really close. So we really don't even need to mess with this, but you know me, I'm going to do it anyway. But that should be pretty good. So it's around the 0, 1 to 2, just kind of fluctuates. And you can see there also around 1 to 2 thousandths. All right, so just a super quick and easy way that we can align parts like this over here on the machine, doing plate work like this. So from here, I need to go ahead and engage the magnets. There's a hex on both sides there, and I have the wrenches, and we'll go ahead and mag it down. All right, so here's where you turn the magnet on. They give you these little adapters and a wrench that you can use. It should be magged on, but I'm going to do this side before I bump it. All right, they're both on. I hope they hold. They should. They have a lot of holding power, just one. So I think that's it. Nice little setup. Looking forward to seeing it being cut. I am going to go ahead and probe the plate in just to be sure that I'm in the center of the plate. I should have this scaled measurement within less than a 16th. I'd say within a 32nd, but we've got plenty of clearance. So if it's offset one side to the other, 32nd, we're still not going to hit these magnets. So this is going to be our Z0. We're going to be taking 30 thousandths off. I modified the program, by the way, off camera. I decided when I first modeled this up, I was going to be clamping it in some Talon grips. And I decided to change the program. We're going to use the magnets, which is what we've been working on. And so really all we need to do is just clean up both sides nice and flat. So we're going to take 30 thousandths off the top, 30 thousandths off the bottom with a finished thickness of 15/16. So we'll start with our Z0. That'll be our Z0. Now, when I go to do the bottom side, I need to probe the top of the vise because that'll be our 0 point for that side for Z. All right, let me reset and we'll do both X and Y now. This will get our X in the center. Okay, reset for Y. Okay, we are ready. I'm going to gently lift out of here. Okay, I'm ready to start cutting on this, and I am going to be running flood cooling on everything. I'm going to try to get you the best video I can. We'll go from there. Take everything nice and easy. We only got one part to make, and hopefully it's not going to do anything drastic or crash on us. All right. Run program, hit start and cycle start. I'm just going to check my screen before we actually engage the cut there. And 0.0312, that looks right. Seems okay. I'm going to take it up to 100% on rapid. 25 inches a minute on our feed there, running 840 RPM. Okay, so far so good. Optional stop, cycle start. All right, so this is going to be our tool change position here. I just wanted to go ahead and take a look at it. I think it's going to be good. We'll just continue on with it now. Again, all the tools, we're going to be doing a manual tool change on these guys. Everything looks good on that. Okay, it wants tool number 31. That's why I love putting these labels on them, so I'll know exactly what we got. This is the one that I'm most nervous about, but we're not taking a lot of material. We're really only taking like 30 thousandths a pass, and I'm going around it 2 times. All right, disengage coolant, and I want to walk this down. Make sure it looks good. I'm checking my distance on the screen. All right. There we go. That's at 100% of our feed rate. Yeah, I think it's doing just fine there. Adjusted that coolant. Seems to be handling it pretty good. Let me see if I can get you a little clearer shot now. It's not splashing everywhere on me. All right, that went well. I was really nervous about that, but I could tell that there was nothing to be nervous about, and it looks good. It looks really nice. Okay, tool change to 32. Let's keep it going. Now we got some spotting to do. We're just using a 1/2-inch spot drill to spot all of our hole locations now. I'm gonna bring this down nice and gentle and stop it about there. Let's turn our coolant off. We'll do one without coolant. We'll get there. Yeah, okay. 1 sec. Just verify that. There's our spot. Okay. Turn our coolant back on. Kick our rapids back up. I'm running all of our high-speed steel drills at 90 feet a minute. And the spot's going down a 1/16 into the part. Okay, time for the next cutter. Tool number 33. This one should be our 33/64, Chicago Latrobe, split point. Getting a little of that coolant down further down the shank of the drill there. Tool reset, cycle start. And again, I'm going to verify this before we go all the way down. Checking my distance. It's 100 thousandths there. I think we should be good. I don't have a very aggressive feed on this. If I remember right, I believe we set it at 6 thousandths per revolution on the feed. All right, that's working well. Go ahead and change our tool. We should be going in with 34 now. And tool number 34. This should be our, I believe it's 10.5 millimeter drill bit. Okay, that's looking good. So there'll be 2 of these holes drilled. All right, looking good. I believe our next one's going to be the 8.5 I'm sorry, 8.5 millimeter. 35. All right, we got a 8.5 millimeter. This is our tap size. Every one of these tools, I'm bringing it down close and I'm just making sure that everything's looking like it's matching up good, and it is. All right. All right, tool change from 35 to 36. This one's going to be our, I'm trying to remember which one, I think it was 31/64. Yes, that's for the 3 holes in the center. I was trying to remember where we were. Let me check coolant on that. Looking pretty good. We can give it a little more, get these up. I like that right there. Tool reset. Yep. Okay. Everything is going well. Okay, tool change. 37. All right, this is going to be our .499 reamer. So 1 thou under reamer. And I'm going to be excited to see, does it actually ream at .499? Better look at what we got going on there. Okay. Tool reset, start. Okay. Lower that coolant down a little bit closer like that. Okay, here we go. 100%. So I can see one mistake I made there. It's not, it doesn't come up in the same retract feed rate as the other tools, but that's okay. Just making our one part here. All right, next up is going to be our tapping, tool number 38. So here's our tap. This is an M10 by 1.5. We are using, this is the Technics Microfloat, and what this does, let me pull it from the collet side. You have a little bit of axial float there that allows for a little bit of misalignment. You know, as it's going through its Z movement, it just allows for a little bit of misalignment there. All right, I'm really nervous about this. It should work. Let's hope that it does. I'm gonna hide behind the door on this side. All right. Well, it worked. You can see how fast that goes. Cycle start. And I will point out, I did not design it to go all the way through the plate there. I do have some hand taps, and I know it drives Kevin crazy, but I told him, I said, I can simply just run a hand tap through there to make it deeper if I need to. But that worked well, okay? Some nice pretty chips coming off that. All right, next up is tool number 39. This is one of my 1/2-inch end mills right here. This is an Imco 6 flute, and it's always worked really well for doing counterbores, and that's all I'm using it for, is to do the counterbores for the 4 holes there. Now, this is probably going to spray everywhere, so I'm going to oh, I'm sorry, that's right. We're doing the keyways first. Keyways. I am gonna get behind the doors though. All right, let's get some coolant on. Sounds good. We're using the adaptive tool path. Now we're doing the counterbores there. I'm just letting it run. Just using one of our board tool cycles for that. Okay, we're down to our last tool for op 1. That did well. I can always tell that it's cutting chips in there, but man, it does such a beautiful job. It leaves a really great finish in there. Okay, last tool for the op. This is a 1/2 inch diameter, 90-degree chamfering tool here. This should break all of our edges, even down here in the key as well. Okay, there we go. Turn that one off. So that'll chamfer all the outside edge and the holes as well. Moving on to the hole chamfering. There it is, guys. That took me a half hour to make, doing all of our little slowdowns like we did there. I'm gonna go ahead and jog all this up. Bring it out here to us. Give it a blow with the air gun here. Magnet is trying to, that's the only drawback of using magnets. It does try to keep some of the chips stuck to the workpiece like that. But we had great success with this. Now, of course, I haven't checked the fits yet. We'll do that next, but happy with it. It looks good. Okay, we've been doing some inspection on our reamed holes and our keyways. We'll start with the 3 reamed holes. So I've got a couple of pin gauges here. This is a .498 and we have a .499. Easy way to measure the diameter of the holes. So here's our 498. Fits in there. So we know that one fits. We have our .499, which should match very closely to the diameter of the reamer that we used. It's got a nice fit in the holes there. There is still a few chips in there. This one seems to be a little bit tighter, but you can see we have our .499 gauge pin fitting in there. All right, and then this particular dowel pin right here that I've had, I mic'd it and it measures exactly .5. I don't think this is the one I'm going to use. It's going to be a little bit too long. I could cut it off, but I'm going to look through my rotary bin. I believe I've got some more. So I'm going to see if I can find the right pin. But I think the ream holes are good. I believe we're just going to leave them there. And whenever I go to press them in, we'll put a little bit of Never Sees on there, and we'll use our hydraulic press and just press those in. Okay, so those are good. We're going to leave those holes alone. Our keyway. So these are the keys. This is one of the keys that bolts to the bottom of the 4th axis. I mic'd it. These have been ground, and it's exactly 18 millimeters. So 0.708 on our micrometer here. Let me see, make sure I'm telling you correctly. Maybe a couple tenths over 708. All right, so key, and what I have done, there's a gauge block stack up of 706. And I can get this gauge block set to sit down in there like so. And that's actually got a nice fit, 706. So 707, I can't get it to fall down in there. So I think what we need to do is go ahead and take 2 thousandths out of the walls of the keyways there. So I'm going to do an adjustment on our wear compensation and run just this right here, just the contour pass that cleans it up, and then we'll check it again and see if we can get. I would like our keys. Well, that thing stuck down to that magnet right there, didn't it? It sure did. I'm trying not to scratch up the surface here, but I messed up. I'm gonna have to get something, and if I pull that off there, it's gonna scratch the hell out of it. I don't want to do that. Anyway, we're gonna just touch this up and see if we can get these keys where they just fit down in there. I don't want it like a press fit. I like it where it would just drop down in there and locate nice and accurately. Okay, we've already got our tool loaded up. We're just gonna run this one little program on this contour. Let's see if we can take a couple thousandths out of the keyway width. All right, simple enough. Now we'll do some measuring on it and see where they cut. Okay, this is a 709 gauge block stack up, and I can't quite get them to go in there. They're tight. I can tell that they're tight. I'm going to take that one off. I'm going to put the 108 gauge block on here. So this should be our 708. And that we can get to fit in there. Or 708. There we go. Okay, that's fitting. Grab our key. That's got a nice fit on it. I can tell that it's got maybe a couple of tenths clearance on there. That's nice. Well, just drop it all the way to the bottom of the machine. All right, I'll get it later. Here's the second one. I was going to flip it over because this is the orientation at which it goes on there. Just like so. That one's actually even a little bit tighter. But anyway, we have a good fit on our keys there now. So I did the negative 2 thousandths wear compensation on the tool in my tool table, and that did the trick. We just ran that one cycle and we've got those opened up nicely. That's got a really good fit on there. All right, so keyways are good now. Our reamed holes, we're gonna leave those alone just like they are. So from here, I've got to unmag it, clean everything off, and I'll probably go ahead and clean the table off too. We need to flip this guy over and get it trammed in nice and square. And then on the back side, we're just gonna be taking that another 32nd of an inch down with the face mill. And then we got 2 counter bores to do for these 2 holes here. And then we'll chamfer all of them.